Hi, welcome to your Finite Math Lesson 3.1. We're going to talk about graphing systems of linear inequalities. So you're going to graph an inequality and a system of inequalities. We're going to start with just one, just to kind of warm up. Remember, when you're graphing a linear inequality, the first thing you do is graph the boundary line for the inequality. You're going to use a dashed line for less than or greater than and a solid line for less than or equal to or greater than or equal to. And the second step is to test a point not on the boundary line to determine whether it is a solution of the inequality. If it is a solution, shade the half plane containing the point. If it is not a solution, shade the other half plane. Alternatively, you can solve so that y is by itself on the left-hand side, and then if it's y less than or equal to, the rest of the equation or inequality statement, you're going to shade below for less than or equal to or less than. If it's greater than or equal to or greater than, you're going to shade above. But that's only if you solve for y. So for instance, if you leave this in the form 3x minus 2y less than negative 6, you wouldn't use that rule because of the less than sign there. The problem is you haven't solved for y yet, because when you solve for y, you end up dividing by negative 2, and that less than gets flipped around to be a greater than. So remember, test a point if you're going to leave the inequality statement in anything other than y, and then greater than or less than the rest of the inequality statement. Okay, so we're going to graph 3x minus 2y less than negative 6 in a coordinate plane. So the first thing you want to do is graph the boundary line. Now, the boundary line is going to be the line 3x minus 2y equals negative 6. If you put that in slope-intercept form, you would subtract the 3x over and then divide by negative 2, and you get y equals negative 3 halves x plus 3. So if you look right here, our y-intercept is at 3, and you have a slope of negative 3 over 2. Okay, so that makes sense. It's got a broken line because it's strictly less than. If we had used the extra pencil lead to do the less than or equal to, we would have extra pencil lead and having a solid line there. All right, now test the point 0, 0, especially if you don't change the boundary line or the inequality statement, actually the inequality statement, to y less than or greater than, because unless y is by itself, you can't do the above and below thing. So if we test 0, 0, you plug in 0 for x, 0 for y, you'll get 3 times 0 minus 2 times 0. So 0 minus 0 is 0 less than negative 6. That's a false statement. So 0, 0 is not a solution. So we don't shade on this side with 0, 0. We shade on the opposite side. Which at first you make up, but this has less than. Yeah, but we haven't solved for y. If we solved for y, we would get y greater than negative 3 halves x plus 3, because when you divide by the negative 2, you'd have to flip the inequality sign around. It is convenient to use 0, 0 as the test point if that's how you're going to test where to shade, but if it lies on the boundary line, you have to choose a different test point. All right. A system of linear inequalities is similar to a system of linear equations, except that you have inequality statements rather than equations. You're going to end up with a bunch of shading, whereas when you just do a system of equations, you don't have that. The solution to the system will be the region where all the individual linear inequalities overlap. So to graph a system of linear inequalities, you follow these steps. You graph each inequality in the system. You may want to use colored pencils to distinguish the different half planes. It makes it look pretty. And then you want to identify the region that is common to all graphs of the inequalities. This region is the graph of the system. If you used colored pencils, then the graph of the system is the region that has been shaded with every color. All right, so let's look at an example. We've got y greater than negative 2x minus 5. So this one's nice. We can do a test point, or because this is y is by itself on the left-hand side, we can go ahead and do, oh, this is greater, so shade above. Inequality 2, we've got y less than or equal to x plus 3. Again, that one's nice because the y is solved for by itself on the left. So on this one, we'll be shaded below. All right. So we're going to graph each inequality system. Use red for y greater than negative 2x minus 5 and blue for y less than or equal to x plus 3. So let's see, negative 2x minus 5. We have a y-intercept at 0, negative 5, so it's down here, and then a slope of negative 2 over 1, so up to left 1, up to left 1. and you use a broken line or a dotted line because it's strictly greater than. Now you can test 0, 0, and if you do, you'll get 0 greater than -2 times 0 minus 5, so 0 greater than -5. That's true, so you'd shade above. Or since y is by itself, you can just go, oh, it's greater than, so I'm going to shade above. All right, for the blue inequality, let's see, we've got x plus 3, so 0, 3 is our y-intercept, and then we have a slope of 1, so up 1, right 1, or down 1, left 1. Either way, you get another point on the line. Because we used extra pencil lead to do the or equal to part, we're going to use extra pencil lead to have a solid line, solid boundary line. Again, you can either just, because the y is by itself on the left, you can go y less than or equal to, so I'm going to shade below, and just shade below, or you can do the test point and test 0, 0. 0 is less than or equal to 0 plus 3, because you'll get 0 less than or equal to 3, and that's true, and so you shade below. And then you step back and you look, where did they overlap? They overlap right here, in this region here. This is the solution, or what's considered the graph of the system. Okay. Identify the region that's common to both. I just talked about that. In this case, it's shaded purple. Sometimes when you use map colors, it might come out to really do blending well. Sometimes it doesn't. You just look for where both shading overlaps. Okay, that's it for today. Make sure you do the problems to try on your own. If you can't do them, either rewatch the video or come in and see me, and we'll get that taken care of. All right, thanks for taking great notes. I will see you in class. I hope you have a good day.